see how many people turn up.
%100% is about the right number. Hello all. Thank you so much all for coming.
Hey, James.
Hello, I'm here.
Hello, James. Maybe we'll give another few minutes as I can see people are still coming.
Yeah, sure. We'll give probably a couple of minutes and then start.
Rahul is on the drive, is he? Try safe, Rahul.
Mute Deepak, mute Deepak. You're on mute, Matt.
Oh, really? Okay. Thanks for that. I mean, since this is a new beginning for this meetup group, I mean, we're not doing a chit chat at the start because we're still building the relationship with our members. So yeah, before the event starts, feel free to unmute and then ask any questions, or we can do even a quick chit chat before this starts. Yeah, to all the members who have joined us today.
Yeah, spot on. Deepak, we're still trying to reactivate this group, and looks like we have more and more people are joining, and we have quite a bit of turnout today. We also have Craig Bryden joining us. How exciting!
Right. Yeah, it'll be good to listen to feedback from the group after the session, and also how do you want us to drive this meetup? If you want to have any topics that you want us to cover, I mean, feel free to always let us know. We're just happy to organize. Should we get started?
I think so. I think that's a good idea. It's almost 5:05 already. Yeah, might as well get started. So thank you so much. We have got James today with us to present how to modernize data infrastructure in Azul. So I'm super excited. I think that we're gonna have something really great stuff to learn. Thank you so much, James, for coming to present. Really excited to have you here.
Yeah, thanks, Jason, for the warm welcome. Happy to be here.
Thanks, Jason. Thanks, James, again, for taking the time out to present to the Queensland Advanced Analytics Meetup Group. So just a quick introduction to the members here, because this is a new beginning for this meetup. I just wanted to give a quick introduction as to what we're planning to do, and also a quick introduction about the organizers, and then I'll hand it over to James to do his magic. Right. So what are we planning to do? We're planning to do fortnightly sessions grouped into specific series. So this series that we are running now is called Let's Talk Data. So we are focusing entirely on data platforms, right? So be it data engineering, or your enterprise data platforms or your data science. We're focusing everything about data. And then we want to focus on diverse topics that could range from product upgrades or new products, best practices, use cases, business value drivers. So we will have a mix of all topics, and it is not always going to be technical or not just always going to be product oriented. We're going to bring in use cases, references. We're going to bring in people who are actually doing work in the industry to come and share their experience. So it's going to be diverse topics. And we also planning to arrange some hands-on workshops on products that actually the user group feels, it'd be that if you feel for a specific product, it'd be good to have a hands-on workshop on. Always let us know, and we are happy to organize. We also have a YouTube channel now where all these sessions are actually recorded and hosted for on-demand consumption. So I'll share the YouTube link. It is also in the meetup group in the description. So you can always go there if you're not able to make it to any other sessions, due to other commitments. And we are also planning to share all the events across the globe that will be useful to the members. So you're aware as to what's happening, and you can just go and join events and learn more. And we would also like to have some networking sessions, to have fun and know each other better and build the relationship within this meetup group, right? So since we are starting back again, that is really important for us. And about the organizers, I'm Deepak. So I'm a solution architect here with Databricks. I'm based in Brisbane. So I've been in this space in the data and AI space for almost 9 years now. So I've worked with IBM Watson and then Oracle in the cloud space, and now with Databricks. So yeah, I'm passionate about, talking to people, coming up with new ideas, inventing new ideas, because yeah, that's what I'm really passionate about that. So I'll leave it to Jason and Brecken to quickly introduce themselves.
Hey, I'm Jason Tan. So I've been in this space probably for about 15 years now. This day I focus on working with the business team to help them to use data and analytics to solve the business problem that they have. And other than that, I just interview the business leader around the world, a high-performing organization using data and analytics. So I'm super excited to chat with everyone in terms of what we are doing on the ground, and people who are making the things happen.
Thanks, Jason. Over to you, Brecken.
Cool. Hi, everyone. So I'm Brecken. I'm the senior guy here. I've been in IT for quite a while, but my data journey is only really just sort of starting off. So I'm essentially a consultant. I've done a lot of work in fintech and payment space. Though, yes, so recently I've had an interest in data and whatnot, and met it with Jason and Deepak, and yeah, just helping out with the meetup. I'm also a data science student at RMIT.
Thanks, Brecken. All right, so that's us who are going to be your organizers for this user group. And yeah, this is the YouTube channel. So I've also pasted this link in the meetup group. You can always take a look at that and bookmark it, and then attend sessions if you're not able to attend the future ones. Yeah, so I'll give a quick intro about James. So James is my buddy in Databricks. So he is a partner solution architect focused on the Microsoft stack, Microsoft side of Databricks. So he's deeply embedded in the Microsoft stack. He has a wealth of knowledge in the Microsoft products, especially in the data and AI space. He's been in the space in the solution architecture space for almost probably decades, and with Oracle and now with Databricks. So yeah, over to you, James. And thanks for doing this presentation to this user group.
Yeah, no worries. Thanks, Deepak. Yeah, so yeah, I guess I have been in for a couple of decades. While I've been around data, a lot of that was actually in data protection and you know, databases, Oracle as well, things like that. But as far as the big data world is concerned, certainly consuming big data has been, you know, only the last few years. You know, prior to Databricks, you know, I did a lot of cloud architecture in both, you know, the Azure and the AWS space. But, you know, as Deepak said, I just now focus on Azure Databricks. So I've got just a presentation that we'll move through fairly quickly through.
I will leave it to you to share your screen. And Jason, can you also please record this if it's, oh, it's already recording, so it's all good. Thanks.
Okay, now let's hope that, is it going to let me share my screen?
Sorry, let me try the control and share the screen. Oh.
Group that can share.
One moment.
You just have to make him a co-host or a host, then you should be able to share the screen.
Done.
Okay, yeah, you are now. You can share now, James.
So I can share my screen now?
Yep.
Yeah, go for it.
I'm getting an exclamation mark, but I'll select it anyway. Oh, okay, just give me a moment. It's okay, it's another computer, my personal computer, there we go, that I'm using, which didn't allow me to share my screen. So hopefully, can you see, I've selected, can you see now?
Yeah, we can see your screen now, James.
Okay, so which screen can you see? Because I've got two.
Azure Databricks.
Excellent, and I'm glad that's the one that I wanted to be sharing because that's the one where the presentation is. Okay, so let me just go into presentation mode first. Okay, so all good?
Yep, looks good.
Okay, fantastic. So let's move through. So we've already done introductions, and apologies if you hear my dog barking. Children are coming home and whatnot. So you know we're living in this COVID world. So just a quick agenda. So an introduction to Azure Databricks. We'll talk about modern data warehousing in Azure. A very, very quick overview of Delta Lake, just because I leverage Delta Lake quite a bit in this demo. Then we'll have a look at the Azure Databricks reference architecture, and this is very much the one that we're talking to customers about in relation to Azure Databricks. And then the JOKKSPA architecture, and then the demo, and then we'll have some Q&A. Okay, so those of you that aren't familiar with Databricks, you know, Databricks is a service, an application, a PaaS service available in Azure, and really it tries to satisfy the demands of three different personas: data engineers, data scientists, and business analysts. And really, what we have is we have a Databricks runtime that has, you know, Spark and Delta Lake and other technologies embedded in it. And over the top of that, we have machine learning runtimes and various integrations that makes it really easy to integrate with certainly the Azure ecosystem, but open source technologies as well. And so as you can see there, we provide a collaborative workspace, we have integration, and it's a scalable, fast platform. And we sit on top of a highly secure security model. Now, modern data warehousing in Azure, so this is a very, very high level architecture, but this is what we call, you know, bringing the best tools to the job architecture. And what that means is that the architectures, the reference architecture that we have in Azure Databricks leverages the best of breed of the various technologies. And so what we have here is we have ADLS Gen 2. So, that's a best of breed storage layer that has a whole slew of features and performance and whatnot. Now, with ADLS Gen 2 coupled with Azure Databricks and in particular Delta Lake, we can bring all of these advanced features around performance and schema enforcement and schema evolution and time travel and all of these features that I'll mention again shortly. And then, so you have a best-in-class storage layer, you have a best-in-class file format in Delta, you have a best-in-class, big compute platform in Azure Databricks, and then you have a best-in-class data warehousing technology in Azure Synapse. And so all of these technologies go together and tightly integrate to provide a really solid foundation for a modern data warehouse. Okay, I'll just let this build out because otherwise it takes a little while. So just a little bit about Delta Lake, because as I mentioned, the do leverage Delta Lake a lot, so it's important just to set the context. And what Delta Lake, it's an open source project that was started by Databricks and has been donated to the open source community. And it's a file format essentially. It's not a replacement for storage. You still need to provide cloud storage for it to sit on top of. But it brings to the table a number of features, particularly around data consistency. So it brings ACID transactions, schema enforcement, and with that schema evolution, which gives you the ability to control the schema as it evolves and prevent data corruption and the incorrect schema, for example, being written down onto your existing data. There's also a number of DML enhancements as well. There's time travel, which allows you to ask your data lake in Delta, show me what my data set looked like at a certain version or a certain period of time. And there's also performance enhancements as well. So we have data skipping and Z order partitioning and all sorts of features that goes along with it. So the performance features and the data consistency and I like to call them data protection features come about because we take the existing Parquet format, the actual file format that the data itself lives in, and we encapsulate that with a transaction log. So very similar to a relational database archive log or redo log, if you come from the database world, which is actually just a JSON format anyway. So readable with text files, text editors. Just if you want to have a look at the JSON, that is. Okay, so that's Delta. So again, I'll just build this out. So this is again our reference architecture, but with a little bit more detail. And this architecture satisfies the 4 use cases that we see, which is batch, streaming, machine learning, and data science, as well as analytics, advanced analytics, and BI. And really, what we do is, if you have a look on the left-hand side, you've got all different types of data coming in. So everything from unstructured, semi-structured, and structured, relational data coming in, and streaming data as well from maybe IoT sensors coming in from the left, being ingested in either via an event hub, Kafka stream, that kind of thing, or being managed by a Azure Data Factory, so like a orchestration scheduling mechanism like ADF that we tightly integrate with as well. And that really brings the data in, and we land it in Delta Lake, and from there we're able to do all sorts of ETL operations on it and essentially evolve the quality of the data. So you can see there we go from bronze just through to silver and then finally gold. So really that represents as a series of refinements and I guess increasing the quality of the data, and that may be through feature engineering for machine learning or aggregation for later consumption in analytics tools like Power BI or Redash or uploading into Synapse, the data warehouse. So we also have ML flow and AML there on the diagram. So In a lot of cases, data coming from your silver table, this may be still high resolution data, but has, a number of columns stripped out that are not needed for machine learning training. That can be fed into machine learning models in Azure Databricks, all managed by MLflow, and then finally deployed via Azure Machine Learning. And of course, in step 4, we also have the various consumption applications and systems. So, uploading refined data into Synapse for maybe more analytics, maybe, mixing with relational data coming from a SQL database, and then finally surfacing into Power BI, or it might be going up into a Cosmos DB document database for consumption in an app, for example, a key value store, maybe to maintain state in an app. Okay, so one last slide, and then we'll get into the demo. So what we have here is, this is the JOKKSPA architecture. And so what I have is, I have an application on the left, and when that application runs, it makes a connection to Cosmos DB and basically queries the database, the Cosmos DB database, and gets the most recent flight number and iterates on that, and then gets that number down. It then can do two things. It can output a file for batch upload. So this program, what it does, and you'll see shortly, it talks to an application to extract telemetry data. So it can either output that telemetry data into a single file, and then using ADF, it can do a batch upload into Delta, or it can talk directly to an Azure Event Hub for streaming use cases. And so we have data coming in from Event Hub or ADF in the case of the batch operation, and being landed into Azure Databricks. And so this is all stored in ADLS Gen 2 in Azure in the Delta format. From a security perspective, Azure Active Directory is providing all of the authentication mechanism, and Azure Key Vault provides the key vault for various secrets that are used for connection strings and that kind of thing. Now, all of the code is stored in Azure DevOps, including the Data Factory pipelines that we'll have a look at. And most of the work really is occurring in Azure Databricks, with aggregated data then being uploaded into Synapse for final consumption in Power BI. And of course, Power BI can also talk directly to Azure Databricks for visualizing data that's in Delta. So that's the architecture. So let's now end this, and we will have a look at, so hopefully you can still see my screen. Now what I'm going to do is I'm going to get rid of PowerPoint. Okay, so what we have is, we have a program some of you may be familiar with, called Kerbal Space Program. So this is a program that allows you to create rockets and launch them and do all sorts of interesting things with rockets. And the interesting thing is it's very, very accurate. It's got a very, very accurate physics engine, and you're able to extract data out of the program and essentially create your own rocketing program. So that's what we'll be doing. But firstly, let's just have a quick look before we launch a rocket. We're just going to have a look at some of the integrations. Now, firstly, I've got my application, or everything residing in this single resource group in Azure. So you can see I've got storage accounts. I've got a virtual machine that's actually used for my Power BI component. I've got a Key Vault, I've got a SQL data warehouse, Cosmos DB, I've got an Event Hub namespace and an Event Hub. I've got an Azure Data Factory. I've got, of course, an Azure Databricks workspace, and the other components like virtual networks and things like that that are required for everything to work. Okay, so now I mentioned, before we get into the launching a rocket, I mentioned ADF. So what we have here is, I have a, let me just minimize my screen a little bit. Within ADF, you have these activities, so Databricks-specific activities that allow you to execute a notebook, for example, upload a jar file, or execute a Python script. So I have I've got a workflow here that basically looks for a file, a gzip file arriving in the storage account bucket. When it notices that the file arrives, it triggers this job, it uncompresses the data, it deletes the original zip, and then it calls an Azure Databricks notebook to do a batch ingestion of data. So what that does is it grabs the data, which is pipe separated, it grabs it out of the storage account, it runs an ETL operation on it, and it uploads it into Delta. So that's batch. We won't actually be demoing batch. We'll be looking at the Event Hub streaming in this example. Now, just before I get into Databricks, so I mentioned all of the code I've got in my Azure DevOps source code repository. Just quickly having a look at the client. I've got this script. It's just a Python. Let me, if you can see that, okay. And essentially it's a Python script that will talk to the application. It'll extract telemetry information. So you can see I'm getting all sorts of heading, speed, altitude. I'm getting a number of parameters that are very important for orbital mechanics, which is apoapsis and periapsis. So apoapsis is the maximum distance. So if you imagine an orbit, most orbits are elliptical. The apoapsis is the furthest distance that the spacecraft or asteroid or whatever is orbiting from the object that it's orbiting. And so periapsis is the closest. So in an elliptical orbit, you'll have an apoapsis and then you have a smaller periapsis. So we also have various G-force, dynamic pressure and static pressure features, parameters as well that we're getting. And essentially we attach all of this up and we send it up into the Event Hub stream. Okay, so let's get going. So, so I'm in Databricks and I've got a cluster running and, oh, just before we go, I mentioned the batch. Here's the actual notebook itself that runs that batch operation that I mentioned in ADF. So under demo, so first of all, we're going to look at live telemetry. Okay, so in Databricks notebooks, you know, to execute a cell, shift return. Now, what I'm going to do is just set up some various connection parameters first. And what I'm going to do as well is kick off, let's get the launch vehicle going. So I'm going to revert flight. We're going to revert to launch. Okay, now I'm going to turn on, I want to be able to see the apoapsis and periapsis. So we'll put stability control on. We want full speed initially. And now I'm going to run my flight log program. Now what it's doing, as I mentioned, it talks to Cosmos, grabs the next flight number, and it determined that the flight number for this mission is flight 32. And now it's sending that data at 1 Hertz up to the Event Hub. So let's continue setting up these parameters. So I'm just defining various connection information. And now I'm actually connecting to or defining the stream. So using structured streaming. So what we should do now is verify that we're actually getting data through. So we can redirect off the stream, and we just want to make sure that we're actually getting some data through before we proceed. So this is actually the first time I've demoed my new environment. So hopefully everything goes well. But as a lot of us have had when we've demoed things, things can go wrong. But things are going well so far. So we can see this is the data coming in, flight number 32. So that's correct. So we're up to 20 rows already. So that's great. So we're reading off the stream, and that's just executing a simple display command. Now I'll cancel that. Okay, so well, let's actually read directly off the stream again, but actually break down, extract out these values. So I've got all of these parameters that are coming in on that telemetry stream. And we haven't launched yet, which is correct. And so you can see this will continue to grow, but we're sort of hovering around an altitude of 76 meters, which is, I switch to altitude. Yeah, so it's about right. Okay, let's cancel that. So, all right, now what we're going to do is I mentioned Delta. So one of the beauties of Delta is that you can have unified batch and streaming, which means I can write data into a Delta Lake table, and while it's having data streamed to it, I can read off the stream, or I can write, or I can read off that that data set as if it was batch. So unified batch and streaming, which is a really, really good feature. What I'm going to do is kick off this read stream that is now creating a Delta table, and it's writing out to this Delta table. All right, and I'm just now defining a table, or actually a view in the Hive Metastore, so I can run some SQL against it as well. Now I've got the data coming in. Now I can read off the Delta. So let's just verify that we're now reading. Yep, so this is data coming out of Delta as opposed to reading it directly off the stream. So that's good. Okay, so we're going to get ready to launch. So this is just demoing that I can actually do SQL as well. So this was a Python example. I've got an SQL example here, which is just providing the same information. So I'll cancel that. Okay. So next we're actually going to run this command. We're still there. Okay, so this is a bit of SQL that is again pulling data off, reading it out of the data lake, and in fact I need to change it. You can see my previous flight 31, but we're now flight 32. So let me change that. So let me cancel that. I'll change it to flight 32. Now we're actually not going to see anything, because one of the things is I've got MET, which is mission elapsed time, is, it has to be above 0. Now the clock only starts ticking just like in real rockets when we actually launch. So we're not going to see anything here while it's just sitting there waiting to launch. But let's get ready to launch. Now, what we're going to be looking for is, to get into orbit, we need to have an apoapsis of 100 kilometers. So as soon as we get an apoapsis of 100, we'll shut the engines down, and then we'll coast up to apoapsis, and then we'll need to circularize the orbit. If we don't do that successfully, then we'll either re-enter and burn up. Now, the other thing is I've got a liquid and solid rocket, and we're going to have to actually throttle back initially after launch with the liquid motor, because the dynamic pressure, which is known as Q or max Q, in the lower parts of the atmosphere can cause all sorts of heating effects and can be damaging. We'll actually have a look at that in our analysis later on. But we're ready to go. So I've got full power set. I'll just admit. I don't know, Deepak, can you be admitting? Are you also seeing people requesting entry?
Sorry, what was it? What was it, James?
I keep seeing on my screen someone wants entry. I'm just wondering, are you seeing that as well? And can you click on it?
Yeah. Yeah, I mean, I think Jason's taking care of that.
Oh, okay, fantastic. All right. So we're ready to go. Okay, so let's go. So I'm going to launch. Now, initially, I'm just going to throttle back. Now, normally, I think the screen sharing is actually slowing things down a little bit because normally this actually happens much faster. Okay, so you can see our solid propellant, and you can see we're already now reading off the screen. So we'll have a look at this shortly. So mission elapsed time, number of seconds from launch, and we're looking at apoapsis and altitude. And we need to start arcing over as well. So to get into orbit, we need to do what's called a gravity turn, which means we need to start heading east so that we can utilize the horizontal velocity of the rocket. Okay, solid fuel is gone, so we're going to drop our first set of stages. Now we're going to go back to full power and keep the gravity turn going. Now it's important that we're watching our apoapsis. As soon as we get to 100 kilometers, we're going to cut the power. Because we're going to need fuel to circularize the orbit. So we're getting rid of atmospheric heating now.
So what's the telemetry throughput here, James?
So just let me cut our engine. We're just about at 100 kilometers. Okay, engine cut, right. So we're going to continue to rise. We've got enough vertical speed to hit 100 kilometers. So while that's just happening, we'll go back over here and have a look at what we're seeing in the telemetry screen. So as we're reading off the screen here, off the event hub, we're seeing the rocket climb in altitude, and I'm just expand that a little bit more. So you can see here the orange line is our apoapsis, and that corresponds down here, 101 kilometers, and our altitude here is continuing to climb. So, and you can see here, we initially went up, and because after we did staging, our apoapsis, predicted apoapsis came off because we were slowing down thrust or reducing thrust. So we're going to continue to get up to 100 kilometers. So while that is going, we've got, let me change this to 32. We can also have a look at our available thrust and our current thrust curves. So this blue line will continue up. Now we can't see, there's another line, the periapsis. We can't see that because that's below, it's well below zero because we haven't circularized the orbit yet. Okay, so let's have a look at our thrust. Oh, I didn't think you'd be hearing music. Apologies for that. That's the signal to let us know that we've passed 70 kilometers, which is the Kármán line, which means we're now in space. Theoretically, we're in space. So you can see here, so with this mission, we started off 600 kilonewtons of thrust. We quickly throttled back with our liquid motor. The total thrust continued to climb because atmospheric pressure was going down, and so that actually increases our specific impulse. And then we jettisoned our solid stage, continued up, and then we throttled up to full speed, 100% liquid thrust once we were through maximum dynamic pressure. We continued up until we got to this point, which is about 52 seconds into the flight, where we cut power to zero because we knew that we were going to get to our 100 kilometer apoapsis. And that actually correspond here. You can see there where we shut down right on 100 kilometers apoapsis. All right. So we'll just let that, we're getting close to circularizing the orbit. So I'll just, before we jump to the next notebook, I'll just get us into orbit, otherwise we'll just re-enter. Okay, so we want to go prograde, which means that we're going to use the reaction control wheels to use gyroscopic influences to get the rocket pointing towards this indicator. So this indicator will continue to fall down to the horizon line. Now what we want to do, once we hit that, or very close to that 100 kilometers, we're going to full power again, and we're going to see our periapsis rise. We need it to be above 70 kilometers, otherwise periapsis will be in the atmosphere and will burn up. So we're just about there, and we're going to go to full power. In fact, we have enough that we can start full power now. Now this will probably also raise our apoapsis as well, a little bit. Hopefully not. We roughly want to circle 100 kilometer orbit, but we may not get that. And the other thing is we want some fuel left in the tank so that we can do a deorbit burn. Otherwise, we'll just be orbiting forever. You can see here from our telemetry stream, our apoapsis is already continuing to rise. Okay, Harrison, second stage. Okay, now if we don't, okay, well, I needed to shut the engine down. Otherwise, if we used up all our fuel, we wouldn't get back to Earth. So that's good enough. We're above the Kármán line, which means that we won't hit the atmosphere at 70 kilometers. We can have a look at our orbit by going into map view. And so this is showing us what our orbit is. So periapsis at 81 kilometers, apoapsis at 295 kilometers. All right, so we're now going to leave Kerbal Space Program for the moment. You can see here as well, there's that, there's our apoapsis up at 295, and our altitude also will continue to rise. And you can see there's our circularizing the orbit burn. Okay, so what we're going to do now is we're going to close that query, and we don't really need this one anymore, so we'll cancel that. And can you hear the music, by the way? Or should I shut the music off? I thought I'd turn that off. Okay, so this was an example of, yeah, Deepak?
Yeah, no, the music is very low, so that's not a problem.
It's not a problem, or it is?
It's not.
Oh, okay. I might turn it down a little bit. Okay, so this was an example of so we're writing data into Delta off an Azure Event Hub. So writing it down into Delta, and we've been able to read directly off that Delta file. So that's our live telemetry, and that will we can continue to write to that. So next, let's go now to flight analysis.
So James, there is a question in the chat.
Yeah.
Where Adam's asking, what's the flow? So it is sensor data to data lake to event grid to service bus to Azure function to SQL on warehouse. I mean, I think it'll be good if you can summarize the end-to-end flow here. So it's sensor data to event hubs to Databricks Delta, and then you're directly querying that using a streaming job or using
right. So if I bring the presentation back up. So what we have is we have data coming in from, for example, it might be an IoT stream And so what we have is so this is the application that's happening over here. So this is pulling data out. It's flowing through the Event Hub, so it's being uploaded via Azure Event Hub. We're using Databricks. We're reading off the stream using structured streaming, and we're writing that data down into Delta Lake that's being hosted in AWS Gen 2. So what we're going to do after that is we're going to analyze the data in Azure Databricks, reading it out of Delta. So again, doing batch operations off the data. And then what we're going to do is we're going to aggregate the data, find some data sets of interest, and we're going to upload those into Azure Synapse for consumption into Power BI. So there's no, we're not using web apps or anything like that in the solution. So this is just focusing on the data flow into the data lake. Does that answer the question?
Perfect, sounds good. Yep.
Great, okay. So let's leave that there. And I'm just going to turn it down a little bit. Okay, so now we have flight analysis. So what we can do is we can read directly off, well, we've already seen that, reading directly out of Delta. So I'm using Azure Key Vault here. So this is just setting up some connection parameters to extract the key for the connection string out of Azure Key Vault. And what I'm doing is I'm creating a data frame just off that Delta table. Now I'm not going to, here's an example of optimizing query performance. So with Delta, there's a couple of operations, a vacuum and an optimize operation that can really reduce the amount of files that you've got in your Delta Lake. It can coalesce them all and also optimize them from a performance perspective. This data set now that I'm using up to Flight 32 is actually very big. So I've run that this optimized before we started, so we won't run it again. We've sort of already seen this, so I'm not going to spend any time here, but again, we can read directly off the stream. So here's an example of reading off the data set. Now this is for Flight 13, which was obviously a previous flight. And so you can see very similar flight profile, but in this case, we didn't raise the apoapsis. So this actual flight was a suborbital flight. Now, once we have the data frame, we can convert it to koalas. So koalas is the Spark aware but pandas compatible software library available for well, certainly Python. And what we're doing here is just a quick sort of demo. Is very, very easy to convert the data frame into koalas. So koalas recommend having a look at koalas, particularly if you use a lot of pandas that want to leverage the Spark engine. So with that koalas data frame, I can run a very simple plot operation on this. So just using matplotlib. And again, this was for flight 13. So all we're having a look at here is again reading directly off the Delta Lake. So I won't spend too much time through there. So all right, so now what we'll do is have a look at, again, this is similar information that we looked at before. This is for a previous flight. So here's an example of a typical flight where we have an apoapsis, and this is the altitude that the rocket was the altitude as it fluctuated between the apoapsis and periapsis. And again, I've got another graph here, and here you can actually see it bound between, in green we have the apoapsis and periapsis and the sinusoidal nature of the vehicle as it travels through its orbit. Now, some other things that we can have a look at is the dynamic pressure and static pressure. So this was again from a previous flight, and I'll execute it again on this flight so that you can see that we are actually reading off the live data frame. But for here we have we're using matplotlib just to graph the launch sequence and the re-entry sequence, and we're having a look at the total air temperature of the vehicle and the pressure. So that was that dynamic pressure through the initial phases of the flight and the later stages of the flight. Falls off like a brick wall here, just because when you're in orbit, there is no air, so it's basically zero. So as soon as you hit the atmosphere, it starts to register. So this is really, an example of being able to read directly off that data frame. One data set, batch and streaming. Okay, so let's now do some aggregations in preparation of loading this into Synapse. So I've got to select here, and what this is going to do, it's going to do some fairly simple aggregations. So I should now get flight 32 included in this list as we don't have it yet. Have I created the all flights? I may not have created the all flights yet. Yeah.
Is it probably you just have to sort it?
That's 28. Did I want that?
Yeah, it's
oh yeah, there it is. So 32. So that's the current flight. Now again, just another example of an aggregation. So we may decide that okay, so this is here's some aggregations that we want to use, and we want to upload these into our data warehouse. So what we'll do now is we'll switch to our SQL data warehouse integration. Now, again, I've got some connection string information in here, so I'm just going to set that up. Okay, now what I can also do is just come across to Cosmos, and I'm actually now going to connect to Cosmos, and I'm going to get some mission information out of Cosmos. Now I should now have the flight 32 now should be in there as well. Let's give this a moment. Actually, this notebook hadn't been attached to the cluster, so sometimes the first time you run it, it takes a moment just to attach. So while I was doing that, oh, here we go. Okay, so if we have a look in here, I should now have, and so there's that flight 32. So that's now, and I've just written this out to my DBFS mount point. So currently the Databricks 7 runtime doesn't support the Cosmos DB connector, but that should be supported very soon. It's an open source project, so it shouldn't be too long before we get 7 support for Cosmos DB. Okay, so let's now go back to our SQL data warehouse. Okay, so we've done that, and again we can read that information out of that table, which is that which we've already seen. And so now, again, I'm doing some analysis here And I may decide that at this point, I like this information. This is the average altitude, the average, the maximum periapsis and apoapsis, and I want to load this into Synapse. So I define my my query here. So I've got an orbital summary data frame with a query, and now what I'm going to do is write this directly into SQL DW. So just to prove nothing up my sleeve, if I go to here and I've got my existing orbital summary, if I just do a execute this, so I'm now talking to my I wasn't expecting that. Okay, so so flight 31 is the most recent in the table. So what we're going to do is we're going to now override it. Now, of course, you can do insert operations as well. So let's take that data frame and we're going to upload it into Synapse. And so you may have noticed there I did a copy. As of the version 7 runtime, we support the copy into T-SQL command for uploading into Synapse. So you can still use Polybase if you like, but you don't have to. Okay, so let's now confirm that I've now got that in my table. And so there it is, 32. Now this information, the average altitude is going to be wrong because we're actually still in orbit. But so I've got it in my Synapse database, and what I want to do is I'm going to have a look at it in Power BI. So what I have here is now this example here. I mentioned in Power BI we can go direct to Spark. So if you have a look under more connections here, then you'll see under Azure we have Azure Databricks, and so you can talk directly to the Spark cluster and extract the data out. Now that's actually what this table is. It's making a connection to the table that I extracted from Cosmos. So it's not actually reading out of Cosmos. It's reading out of the table that I created once I read out of Cosmos and loaded it into Power BI. Now, over here we have orbital summary. So in this example, this is actually connecting to Synapse. So we mentioned that after data is being curated and aggregated, you may then want to load it into Synapse SQL DW for consumption in your Power BI tools. And that's what's happening here. So if I do a refresh, we should see information for flight 32 show up. Okay, so we got another one, and so there it is. So flight number 32, we have, no, that's 31, there's 32, there's 32. There's 32, and those numbers will change as I update the SQL DW. Okay, so I noticed that we've got only 2 minutes to go. I know we walked through quite a lot there. I think that's it for my demo. So what we saw how you can get data out of, you can use ADF to manage a pipeline to get data into Databricks and land it into Delta. We also saw how we could write data up into Event Hub, and we can consume the data off the Event Hub and land it into a Delta Lake table, and then we can read the stream, and so we can see live data coming off the stream, but we can also read data in a batch mode off the stream. And then we can take that data, we can aggregate it, we can refine it, we can do whatever kind of analysis that we want to do, and then we can upload that into our data warehouse for consumption downstream. So if we now look back at the PowerPoint, so we saw all of those features. In this current version, I have the Azure SQL database is working, and I am populating tables for that, but I'm not actually consuming that data yet. So that's why these lines are dashed, but they will end up being full lines once I've got those components working. Okay, so just was that interested in any questions at all? We'll just go back to live telemetry and do our deorbit burn while we've got this running. The one, yeah. And is that running? Oh, let's execute it. We'll need the most, get the most up-to-date information out of Delta. Okay, so what we need to do is we need to deorbit at periapsis. We don't really have time for that, so we're just going to go into retrograde motion and prepare for a deorbit burn, which should drop our periapsis. We need our periapsis to be below 70 kilometers to re-enter the atmosphere. So there we go. So so we can now successfully re-enter the atmosphere, and I'll just stage the rocket and get ready for re-entry. Now on our stream, we will see our, in fact, if we have a look at periapsis here.
James, considering the amount of time, should we open up for questions?
No time for questions?
Yeah, that's what I mean. That's what I was asking. Should we open up for questions because it's already 6?
Yeah, sure.
Yeah. I mean, folks on the call, if you guys have any questions as to how these things have been tied together, what are the components involved? You know, how is the architecture stitched? I mean, what's needed to actually build a use case like this? I mean, you can pretty much ask any question, unmute yourself and please ask, or just type it in the chat window and we'll get it answered.
It's not actually seeing. Let's see the chat window.
Yeah, so I think that was a demo on how to do like an IoT based use case in real time, doing some real time data processing, you know, using Databricks, and how to unify batch and streaming, and also use a data warehouse in the end to do some real time operational dashboards. So you saw multiple components of the Azure Data Platform come together. So that is Event Hub, Databricks, Synapse, part of Data Factory, you know, for this and Cosmos DB as well. So you guys have any questions?
No questions from me though, James. That was awesome though. Thank you very much.
Yeah, no worries. Thanks.
Right. If there are no questions, okay, there's one question, James, from Adam. So what is the hosting requirements for Databricks?
So for Azure Databricks, it's a full PaaS solution. So what we do is all you need to create is well, in Azure, you'd have a resource group and you would create a workspace. In fact, I'll show you if I'm still displaying my screen. So you can see here, so this is the workspace. So what this is required for you to be able to log into the platform and then create clusters. So if I go to clusters down here, I've got cluster definitions running. Now, when I create a cluster, I get to decide, you know, how big the nodes are, how many, you know, if I want auto scaling and what am I auto scaling, you know, from and to. And so when a cluster starts, we will deploy virtual machines in Azure, and you know, using Docker images and you know, all of the necessary data to make the whole platform work. And so while you've got a cluster running, you will have these virtual machines, you know, running in your Azure tenancy. So when you tear down a cluster, those nodes will shut down and will be gone. So you don't actually install it on VMs at all. It's all managed as part of the solution. Now, having said that, you can create your own Docker files if you've got specific requirements for certain components that you want in a Docker image, provided you do hit the requirements. So there's a number of packages that we require to be in the Docker image so that we can talk to it. So as long as they're met, then you can define your own Docker images.
Thanks for that. There's another question from our Singh asking, can we implement CDC using Delta Lake on unstructured data? Yeah, I think I can probably answer this one. If you wanted to handle unstructured data, your data lake is where you're going to store your data anyway, right? And if you want to use Delta on top of it, you'll have to build some logic to actually transform your unstructured data into a matrix of features. Technically, that's what is required for you to build a machine learning model or process anything with your unstructured data, and then you will store that transformed matrix of features into a Delta Lake table. So if you implement this pipeline, you can automate this pipeline to automatically pick any new landing images or videos, and then you can transform that and store it in Delta automatically. And then once it's stored in Delta, you can also automate the other pipelines on top of it as well. Does that answer your question, Arsing? Perfect. Right.
So there's actually another question, is a VM scale set underneath? So it's actually changing. So currently in the Australian region, no. However, VM scale sets will be coming. There's a load balancer upgrade that needs to happen. It's only happened in 1 or 2 of the US regions. Once that load balancer upgrade happens in the Australian region, then the VMs will be deployed in a scale set at the back end. But it's not something you really have to worry about, because all of the spin up and spin down of the VMs is all managed by Databricks anyway.
Oh,
thanks, James.
Hi, Michelle here. Thanks, James, for the demo. It was a great one. Regarding Synapse, I was just wondering what's the benefits of adding this Synapse, since Power BI can query directly from Delta Lake. What are the use case where we do need a Synapse versus where we can directly source the data from Delta Lake?
So yeah, so that's a great question. We get this kind of question quite a lot. So Synapse is still for very low latency, high frequency kind of queries. Synapse is still a better tool for those kind of use cases. The other area where most organizations will look at a combination of Azure Databricks to manage their data lake using Delta, but they'll couple it with Synapse because they may have, for example, they may have relational data coming in from SQL Server that has certain foreign key and primary key constraints that they want to preserve. So you can, while you don't have the same constraint capability in Azure Synapse as you do in SQL Server, there are still capabilities there. So you may want to maintain those kind of relationships. So one of the things with hitting Databricks, so the Spark, it's Spark connector under the hood, hitting it Spark from Power BI, is while the connector is much better, and we've recently significantly improved both the latency on it as well as the payload, the actual data payload, and also streamlined the authentication mechanism. So now it supports what we call Active Directory pass-through, credential pass-through. Firstly, it does require a cluster to be running, so you do need a Databricks cluster running to be able to get the data out. And one of the beauties of Databricks is that you can spin your clusters up and down very easily on demand. Either in an interactive, cluster in a notepad, like what I've been demoing here, or as part of a job, what we call a Databricks job, where you start the cluster up, you run the notebook, and then you tear it down. And that's what I've got going with my batch operation as part of that ADF workflow. That's actually a jobs cluster that just lives for as long as it needs to for the notebook to run. Typically, a lot of customers will have their Synapse running 24/7 because they may be using it for all sorts of other data warehousing purposes. And so, that's an area where customers say, well, I'm already paying for it running, so I might as well move my data after it's being aggregated into Synapse, and then use Power BI to hit the data set from there.
Yeah, I mean, I can probably add in a dimension to that. So Synapse is a package of multiple products together, right? So it's under the core of Synapse is SQL Data Warehouse, right? So and on top of that, you will have ADF, you'll have data pipelines, and you have Spark pools, which is still in beta. So it's a package of many things. But when you compare the difference, when do you use Databricks and when do you use Synapse, it all comes down to how much data are you processing, and what is your concurrency requirements, right? So that's pretty much it, concurrency and latency. So if you're processing massive amounts of data, and if your data is based out of a data lake, then obviously Databricks is a better fit. And we also have released a new product called SQL Analytics last week, where you can create an MPP cluster for that. Whereas if you're dealing with small amounts of data and you still want high concurrency and low latency, that is where the Databricks is still not there yet, right? To deal with small amounts of data. So if that's how your workload is, then you might have to consider a SQL data warehouse for that. Plus, on top of that, whatever James highlighted, right? If you are coming from a SQL Server background, if you want to preserve your modeling that you already have, and then complement that, then obviously yes, right? So you'll use a SQL data warehouse.
Yeah, great. Thanks, Deepak. Thanks, James.
Sure.
Well, we might probably end the session, considering that we have gone 12 minutes over, but that's good. That was a really great session, James. Thanks for that. More than data, we also learned about space.
Well, look, I thought it's after 5 or after 6 o'clock for me. A lot of the time, a lot of the demos can be a little bit sort of dry. So I thought I might sort of, make it a little bit more interesting, a little bit more fun, but still see an end-to-end data pipeline. So and thanks for this. You're actually the first ones to see this demo. So I appreciate you being guinea pigs, and hope to refine it and get it better with even more features. And ML is the next sort of focus for me in this demo, to do some machine learning on the trajectories and things like that. But that'll take a little while. So I appreciate that.
Thanks for doing it. It was a really good demo. I'll probably send this recording to NASA or SpaceX and see what they feel. If they're going to ask for your resume, I'll probably hit you.
I think Elon Musk has been asking for these already. So thank you so much.
Thanks, James. Really appreciate it. And thanks, folks, for joining, taking the time out. I'll keep you posted about the next meetup and the topic. Just watch out in the meetup notifications. Thanks for joining. Yeah.
Before I quickly let everyone go, I just thought that maybe I'll just do a quick poll. It looks like people seem to prefer the evening section after 5. Anyone agree, or still because this is new and thought is joining us?
I mean, that's what I feel as well. Looks like we had a really good turnout today, as opposed to one. Yeah, I think I'll go for the evening sessions for the future. But So Adam says evening. Thanks, Adam. Yeah, Michael says evening. Ray says evening. Oh, there you go. Everybody likes evening sessions. Then we should do it.
All right. Thank you so much. Thank you, James.
Thanks, guys. Have a good evening, and see you in the next meetup. Cheers, James. Have a good one. See ya.